We'll get started today. We're going to start the discussions around material takeoff. And I think we have a number of estimators that are actually in the profession already. So it's going to be probably old hat for some of y'all. And the rest that are not in the estimating side, it may or may not be new. But we're going to walk through several select disciplines over the next few classes and talk about them. But in the process, we're also going to talk about some general items, and we'll repeat those items each week as just a reminder. Today we'll talk about them a little bit longer, and then we'll talk about them in more detail in class. In less detail, a little faster, classes to come as a reminder. But today we'll then focus a little bit more heavily on earthwork, site work, concrete, grout. And then next week we'll move on to the next topic, which will be buildings, steel, and equipment, mechanical equipment, not construction equipment. So quantity development, also known as material takeoff, we're taking the drawings and even the lists, and we're turning them into a set of quantities that we're going to use as our estimate basis, which is to be labored and priced. So you can look at the quantities in several different ways. It's actually a material that's to be installed. That's the obvious part, but it also represents, in many cases, an activity. And it could even represent several activities instead of one. So a good example is if you take off the area of sheetrock inside of a building, you now have your quantity of sheetrock and you get pricing for it. But at the same time, it represents the activity of installing that sheetrock, taping, floating the sheetrock, texturing the sheetrock, and painting the sheetrock. So you have technically 4 activities represented by the one quantity takeoff. And that can, not all material quantities can translate into several activities in the same way, but some may translate into 2, some may translate into 1, and it's so forth. You just need to know your quantities from that standpoint. But the quantities are a tangible basis that help describe the scope of work as well. Whenever we look at the quantities themselves, we start thinking scope of work. Then a lot of the other items that surround that become a little more abstract to us. Whenever we're talking about the quantities, the level of definition of the quantities is quite important. And the reason I make this point, even though it's subtle, is in the 2 examples I give here, it's easy to say go pour concrete or go install pipe. But unless we really define what that is, it almost becomes completely meaningless. There's some meaning with the term go pour concrete or install pipe, but as we're trying to quantify our scope, it's important to include the right and sufficient data with those quantities to describe what they are so that we can do something with it. And that's important from 2 aspects. One is, as if engineering is providing you the quantities, you need to make sure that engineering is providing you the definition of those quantities adequately. That's an issue that the EPCs face every day. On the other hand, if you're not in an EPC and you're actually developing the quantities on your own, then as you input those quantities into the template, it's, at least from my experience, it's important to make sure that we define those quantities well enough in the estimate template so that we know what we're applying when we go to price and labor that material item. So in other words, instead of saying pour concrete, if we were to say pour 3 30 cubic yard foundations, there's going to be a type 3 foundation, which translates to a pedestal type foundation using 4,000 PSI concrete and a 3-inch mat. Now, from that description, we know what our contact surface area ratios should be for the formwork. We know what our steel reinforcement ratio would be per cubic yard for the foundation. We know we need 4,000 PSI, not 3,000 PSI or 5. And we know there are three. Well, you could either input it 3 times or you could put in 90 cubic yards. So from that standpoint, um, you've got some flexibility there. And then you have a 3-inch mud mat. So it's a different type of concrete. And even if you don't provide a specific quantity for that mud mat, there's certain standards that you could use to come up with it. So the point is trying to drive home is make sure that there's adequate description that is accompanying those quantities, either in what you're receiving or how you're inputting it into the estimate system. So key quantities. So once we're receiving all of these quantities and we're inputting them into an estimate template, and we're making sure that we have decent definition, but there's a lot of confusion that I've run across with people on what key quantities represent. So typically when you look on a summary sheet, the quantities that you see presented should be key quantities only. They are the basis for metrics and ratios and general analysis. And the contents of those key quantities, the definitions of those key quantities do vary by company, but there is a fair amount of regular consistency in them. But whether your company views it one way or views it another, it's important for that company to maintain those practices regularly so that they're consistent project to project, estimate to estimate, so that the metrics and ratios that you're using to judge and analyze your projects and your estimates actually have meaning. Because if you don't follow the rules and one job includes something in, say, piping that another one doesn't, now your metrics don't mean anything because your ratios are starting to be adjusted not by the project scope, but by what you're including, excluding. Some standard key units of measure applied to these key quantities. Site work typically is either cubic yards or square yards. Piling are in inches. Concrete is in cubic yards. Structural steel, tons. Buildings, a lot of times in the industrial world, we look at buildings as inches. But if you are putting more effort into those buildings and they represent a greater portion of your scope, you're likely to capture them as square feet.
Is that because the building's value within an industrial complex is the cheapest?
2 reasons. One is typically they represent 0 to 5% of our scope of work, of our direct field costs. The other is normally we're going to subcontract that because building contractors are much more efficient and therefore less expensive than if you had an industrial contractor try to go in. So we'll just say one building, subcontract it out. And so now it's an each to us more than it is. How much is that per square foot? And there's also a third, and that is a lot of our buildings are modular. It's almost like a piece of equipment in some ways. Our power distribution centers, our motor control centers, our remote instrument enclosures, our analyzer buildings, they're all usually skidded. Meanwhile, a lot of our other buildings that we include, they're not buildings in the sense that you're used to thinking of them, where the interior is finished. If we have labs, if we have an administrative building, if we have an engineering building on the site and we're building the entire site, we're likely to have what you would consider a regular stick-built finished building. But in most cases, our buildings are warehouses, storage areas, they're shelters for like a compressor or a couple of pumps. And it's really a metal structure with skin on it that has very, very basic electrical and HVAC. And the HVAC is usually just ventilation. It's not even air conditioning. I had one job, to give you another example. We actually had $145 million worth of buildings in the project, which is a lot of money. That's not a small scope of work. So whatever building contractor won that job, they won. But the issue was it was a $10 billion scope of work, but we had one compressor that was $75 million. So from that standpoint, the 145 million in buildings starts shrinking in significance pretty quickly.
Yeah, thank you.
No, you're welcome. Then mechanical equipment, usually in eaches, almost always in eaches. Piping, lineal feet, electrical lineal feet, instrumentation in eaches, paint, square feet, possibly in equivalent square feet, but typically square feet, insulation in square feet or equivalent lineal feet, and then fireproofing, cubic yards or square feet. So that's the general standards that you will find. The key concept here is that whenever you're laboring all the related activities and pricing all the items that belong within the category, they're not all going to be quantified according to the key quantity unit of measure. So structural steel is in tons, but the connections may or may not be in tons. And you might have you're potentially going to have other items that are not in tons, such as if you have to field drill a lot of welds, if you have welding, if there's a kicker or something that you're having to weld on, that's going to be in eaches, that's going to be in lineal feet. And you might have some miscellaneous steel that isn't quantified. It's so minor, it's not quantified in tons, it's quantified in square feet or something of that nature. We tend to convert everything into tons. So we will take off grading in square feet, but we'll convert it to tons. We'll take off ladders in lineal feet and convert it to tons. We'll take off handrail in lineal feet and convert it to tons. But it's important to know whether or not you typically quantify those items or not, because some companies will say they're only going to capture in the tonnage the structural members. Everything else is taken off in its square foot, lineal foot, eaches, like safety gates will be eaches. But you still have the dollar value of all those in your mix. But that company is going to have a much higher average labor hours per ton than a company that's converting everything over to tonnage and then back dividing. But you wouldn't convert your fiberglass grading into tonnage. It's not steel. So all of those, and safety gates, they're usually left as eaches. So all that gets blended in along with the welding, along with the drilling. And of course, as you go from light members to extra heavy members, your hours per ton are decreasing. So you need to know your mix before you analyze your metric. That's one example. Another, piping is usually a pretty good example, because in electrical as well, piping lineal foot is your unit of measure that's typical. However, you have valves, they're eaches. You have flange makeups or bolt ups, they're eaches. Your threaded connections, if you have any small threaded pipe, they're in eaches. Your welding is in an each. If you're counting the welds themselves, if it's an unusual weld, you might have it in lineal inches. But either way, none of that is in lineal footage. Your testing is a lump sum. So only the pipe itself is included in the lineal footage, but all those other items are still buried in your average unit labor hours and in your average unit material cost. Electrical, same thing, but we'll have lineal footage against our cable, but we'll have like FT or LFT for lineal footage of tray, or feet for lineal footage of tray. Conduit could be LFC. And then we also have a lot of companies do not count grounding and lightning protection as their key quantity cabling. And the primary purpose is because it doesn't carry a current. Only if there's a short, only if there's lightning and it happens to strike, will it ever carry a current. And not every project includes it. So if you're installing a brand new pump in a brand new facility, then you should at least have grounding. Meanwhile, if you're replacing a pump in an existing facility, the groundings should already be there. So it'll never be included. So there's you might have a new pigtail that runs from the new pump to the existing grounding system, but you won't be installing a new grounding. So they're not consistent and they don't carry a current and they vary by design. Meanwhile, the theory behind your electrical components, either power or control, they're fairly consistent relative to the items that you're installing. So that's what's counted. The high pot testing, the connectivity testing, the terminations of all your cabling, the installation of your tray and your conduit, all those items are still going to be in your hours, and any materials related to them will be in your material costs, but they'll be back divided only by the key quantity. And as long as your company defines how they count things, and then everybody follows that definition consistently, now you'll start to create a regular routine and you will have metrics that's over time become apparent. And those metrics are a very good check. They'll vary by type of job, but once you have a number of a certain type of job, you'll see reoccurring themes. How many hours does it take to install piping of a average diameter? How much pipe do you normally have per piece of equipment? How much concrete do you have per piece of equipment? How many hours per cubic yard do you normally see? What's your cost per cubic yard on an average typical basis, and so on and so forth? So you can actually, it's a good check. You don't want to force a detailed estimate into an expected range. If you can explain why it falls out of a range, then you're perfectly where you need to be. But it's really handy to check the sanity of those estimates. And also, if you maintain those ratios, you can reverse them and start factoring future projects for your class, your FEL1, FEL2 type projects, your class 5 and class 4 estimates. Once they're established, they can work in both directions. Does anybody have any questions about general quantification and key quantities?
I have one comment about the miscellaneous steel when you were talking about the gratings and the ladders and all this miscellaneous steel. When I was my last days in estimating, which was a very long time ago, was as a consultant, and we never go by the ton for miscellaneous steel. We go by the linear foot, the square foot, and so on and so forth. And I guessed what it was, but then when you said it, it just pounded in my head. Because this way it will become more expensive. So I'm giving the client that I'm estimating the job for a little bit of fluff in his estimating. While it's justifiable fluff from my standpoint and his standpoint, the contractor's probably not going to do it this way.
Now we actually take it off by lineal foot, and
then you convert it by ton afterwards.
Then we convert it, yes.
But when you use the unit price, then when you do it by the linear foot or square foot, it's going to be higher than the ton. That's what you said, correct?
We make sure that our pricing aligns with the application. So if we take it off in square foot and then convert everything over to tonnage, we'll apply a price in an hour production by ton. If we apply that first, then we'll apply it by square foot or lineal foot and then convert it back. That's one key important topic that we'll repeat when we get to the pricing class. Is it's important to make sure that your unit of measures that you're quantifying align with the unit of measures that you're applying your rates against. And I know that seems like a real obvious statement, but I've seen people apply short tons to long tons and metric tons to short tons, and they didn't realize that they were applying a square foot price to a ton. Either they weren't experienced or they weren't familiar with it, and it can get real out of whack very quickly if that's not being paid attention to.
Because of the size of the job. Small mistake, it's going to multiply very quickly. You're going to add several millions.
And also, if you're pricing ladders by the lineal foot, then I don't price them that way very often, but you might be looking at $250 per lineal foot or something of that nature. But if you price ladders by the ton, you should be somewhere in the neighborhood of $5,500 per ton versus light steel might be 4,500 and medium steel might be around 3,500. By the time you get to extra heavy, you're at about 1,100 per ton. So it's and it wasn't too long ago when we were having shortages during COVID. We were actually seeing some of the miscellaneous items run up close to $7,000 a ton, which I've only seen that once before, and that was in the 2009 period whenever China was chewing up all the steel and surplus was equal to the base cost. So you're doubling the steel pricing back in 08, 09. This is the first time I've seen us get close to that again. But it's relaxed since the market has kind of sped back up and started producing again. But then I think it was early 22, late 21, early 22, those prices were really skyrocketing. I don't know if anybody else has seen anything similar.
No, I've seen it in at that time I was out of estimating completely, but I've seen it in, you can see the shortage of supplies with the contractors coming back with change orders for lousy items. From my standpoint, it's lousy items, piping and stuff. And they are saying, it's just regular pipe, but it has long lead items. Suddenly it become a long lead item, and it's something, until they just go buy it in Home Depot or something. So, yeah, we've seen that. So you can guess that the price is going up within the change orders that we're receiving from the contractors too.
Yeah,
I'm having the same issue with electrical, even refurbished and used equipment being almost what it would be to buy it brand new. You're paying full price for refurbished and used.
Well, along the lines of electrical, that's a good one. We've been seeing, and I think it's relaxed a little bit now, but we had large transformers requiring up to 18 months to be built and delivered. Have you seen anything like that?
Yeah, the restaurant I just finished, the lead time on the original gear package was 2 years.
2 years.
2 years?
Absolutely ridiculous. At the very, very last minute, we got a refurbished set from Eaton that saved the day, but we had to rebuild the guts and everything. I mean, it was taking parts out of one and basically making our own panel to match, to make spec.
Wow.
We've been doing that too. So instead of like an 8,000 amp panel, we'll just get 4 2,000 amp panels. Instead of waiting the 14 months, we can cut that down to like 5 months or whatever it is.
Yeah.
Wow. Okay. That's good to know.
Good to know, but bad to know.
Well, that's true. I mean, it's making everything challenging, but it's I knew that we were struggling with transformers. Well, I haven't heard anybody discuss the struggles of some of the other equipment like panels. So
where all my gray hair comes from.
Yeah, custom made stuff still takes like 9 or 10 months, but off the shelf stuff like 3-ish months.
It's not just electrical stuff either. It's mechanical stuff, because I had to wait. My project was done for almost 6 months. I had to wait 10 months total for a BACnet controls card put for the HVAC system, so that it could go into the system, so they could control the VAVs from their cell phone and computers.
Yeah, I had the same thing with my VRF system for Mitsubishi. It was a nightmare.
Wow.
Yeah, but steel. So we bid a project a couple of years ago at the height of steel pricing, and the owner said no, and then they came back and priced it a year and a half later when it was normal, and it went from a $6 million package to like a $4.6 million package. So
wow,
that was smart of them to wait.
Yeah, they probably had a feel for things would eventually. I wouldn't say we'll ever go back to normal. I don't think we ever will, but things have normalized somewhat, it seems. Concrete's up. I mean, what we've been experiencing lately is like $165 a cubic yard now for just raw concrete out of the chute. Does that sound familiar? Has anybody? Now that's 4,000 psi. not 3.
Yeah. That's what we just poured in Wilmer, Texas. We poured 1.6 million square feet of it. And that's how much it was. They even had a little batch plant out there, and that's what they were charging us.
Now, I've seen, from my experience, batch plants tend to be a little more expensive, but you have a captive audience, so you're guaranteed. You can save on your transport costs a little bit, and then you're guaranteed your product. Well, I had a job that I bid is about a year ago, but it was in what was the name? It was out in West Texas. It was past the Odessa Permian area, and it was $165 a cubic yard for the concrete, and it was $145 to deliver. If we would have built a batch plant, we might have been able to cut down on the delivery charge that we would have had to pay more for the plant.
You mean
I'm
built
sorry.
it on site?
Yeah, if we would have put the batch, we didn't look into the batch plant. But if we had, I would have suspected that we would have paid more for the concrete, but a lot less for transportation. I don't know if we would have come out cheaper or not, because we never did that investigation. I thought somebody else was going to say something.
Yes, sir. The only quirky thing that I have is for us on transformers, we were going through the same deal. It's about 16-month wait period for Bryan, Texas Utilities for the large scale transformers for us. And we went from 190 a yard over here in Bryan College Station to about 130 a yard. And that's mainly because we work for Habitat for Humanity, so we can leverage that community input. But right now, going rate for us, the new normal, things may have stabilized, but the new normal is very hard to communicate to people who aren't in the industry, like our board members, who cannot fathom the amount of cost increases that have come across the board. So our board is used to building houses between 80 to 100,000, and we're doing about 110, and they're sweating bullets, not understanding that we are doing everything we can to try to keep our cost analysis low, but things are just more expensive nowadays, especially labor in our market. So
labor, people
Oh,
can't find anybody to work.
Exactly.
Anymore. So, well, it's good for those of us that want to work, because it means we're more demand, but that's also bad for the companies that are trying to keep their labor in check. I'm not seeing a drastic increase in craft labor wages, though. We tend to we're pumping up our per diems more than our wages, although we're expecting somewhere like 2.5% to 3% a year. What have y'all seen?
Do you see labor wages, like with the summer strike and labor really striking back? Look at the United Auto Workers, everything going on. Do you see in the industry coming forward that trade labor, especially specialty trade labor, the electrical, the plumbing, HVAC, mechanical, all those folks, do you see them not striking, but do you see wage increases coming, or labor cost increasing overall coming forward?
I think it is, yes.
I do too. You don't have anybody lined out in trade school coming up behind them. Nobody wants to work.
Correct.
My understanding is that the average craft worker today is now 48 years old, and it's just every year it's increasing by about a year. I know that maybe 6 years ago it was 45, and so it's been increasing about half a year per year as a few people enter, but not as many that are leaving. So it's we have a national shortage of craft labor countrywide, all disciplines.
And according to Mike Rowe's podcast that I listened to this weekend, he's saying that the average replacement is for every 5 trade workers that are retiring, only one is coming into the industry.
I heard the same thing, the exact same thing. For every 100, there's 14 replacing.
Yeah.
Another thing I'm seeing is the guys that are getting their like master plumber or master electrician license at a young age, they're not sticking in the trade. They're moving on to like engineering firms, working, like Cleary Zimmerman on my last project here in Bryan College Station. The engineers were all 20-something-year-olds that had been in the trades and gotten their master's license, and now they're no longer in the trade. They're on the engineering side of it.
It's more comfortable. They work in the air conditioning, make a higher salary. And it's probably it's more regular as well. Yeah, I don't know.
That's not comforting. Listening to all this.
Well, I know on the one job that I mentioned before, and it's one of the jobs it's one of the bigger jobs I've worked on and had a lot of history. But we actually brought in welders from the Philippines for a while, and we shipped them, we housed them, we paid them, and then when they were finished, we provided transportation back for them. So it was a great deal for them. It was a great deal for us. That may be the future that we're looking at if we need more and more workers. I'm not saying the future is the Philippines, but the future is outside of the United States.
Well, that's great for the industrial side, but you get into like the local commercial side, like
That's the
we
problem.
can't afford the
Yeah.
import of the labor like that.
Yeah.
Right. We don't have the buying power to be able to bring in outside outsourced labor at that large scale. So for us, is there a resource, John, that you might know of that as estimators and project managers going forward that we can look towards in the next few years to be able to baseline what that cost analysis is on a smaller scale?
Man, I don't know. I actually don't know where we're going to get them from. Other than we have a lot of craft walking across the southern border. I mean, it's just a fact. And a lot of them are very talented. But
are you sure about that? Because I've seen some of them. I mean, some of them are. But
yeah, I'm not saying
of them.
all of them are. Because all of them aren't. And then there's other issues there as well. But a lot of our projects have a lot of talented craft that have come up from the southern border, along with some that are not, but that's true of our own craft here as well. And what we're also experiencing is that because of the shortage, everybody's rising up through the ranks much faster than normally expected or anticipated or even should be. So now we have journeymen that can't operate as a journeyman. They're just journeymen in name, not in title, but not in skill. So we're having to basically decrement our skill level and take a productivity hit for that.
Is that lowering your quality control abilities because you're not getting the knowledge base in at that level, or are you having to lower your quality control standards to meet the competency of what you have?
We cannot lower our quality control standards, but what we have to do is find a way to compensate for it. So
exactly,
one option is that we provide additional training. Another option is that we are carrying a higher journeyman ratio than we used to because the journeymen aren't as capable as they used to be. So now where we used to have maybe a 1-to-1 journeyman apprentice or maybe a 1-to-2 journeyman apprentice, now we have a 2-to-1 journeyman to apprentice to compensate for that, except for the union areas. The union areas, they are trained better. And I'm more partial to open shop, but the union areas admittedly are trained better, but they have other issues in how they go about their practices that actually create a lower productivity. Yeah, because of the rules and regs and strikes and everything. Even though they're better trained, they produce less, which is ironic, but the truth.
I'll tell you stories about the unions up in New York where I came from. They intentionally lowered the productivity rates on purpose so their workers can make more money, and you can't force them.
Yes,
they'll slow
down. They can slow down on you. And there's so many gotchas in the labor agreements. But
anyway.
But good conversation. I'm gonna push us on because we won't cover everything if I don't. But I'm enjoying the conversation. So once we develop our quantities, we're taking them off a drawing, or even if going back to EPC, if engineering is providing them to you, typically engineering is providing them out of a plant download. Either way, when you take off your drawings or you get that 3D plant download, BIM style download, they're neat quantities. And neat quantities represent the intent, but not reality. And I think everybody in this discussion here realizes that. So the way that we recommend, and why? Let's state some of the obvious things. Concrete forms bow, steel and pipe. They are sold in standard lengths, and you might need 8 feet, but you got to buy a 20-foot stick. Things of that. You need 250 feet of cabling, and you have to buy a 500-foot roll, or maybe you need 475 feet. Whatever the circumstances are, you can't get it neatly to match what you want. So reality happens, and you have this increase. In addition to that, as engineering is putting information into the 3D model, as the estimators, whoever else has been delegated the task of quantifying the drawings, things are missed regularly. It's just human nature that something is overlooked, great or small, and a lot of it also depends upon what stage of development things are in and how much time has been allocated to the takeoff effort. So we have a set of allowances that we apply to the quantities to compensate for these. And it's not just a single set of allowances, it's a matrix. As you look at, we're not going to have too many detailed quantities in your FEL 1. You're going to have 0. It's going to be capacity factor type estimating and costing. FEL 2, you're still factoring a little more detailed level, but you could, as you get towards the end of FEL 2, start having some forced details introduced into the estimate. And by the time you get to FEL 3, the estimate's pretty much a detailed based, even though it's all conceptual. So the concept would be, where is the engineering within what stage of completion and accuracy is engineering? And based upon that discussion, you then can determine a design allowance. And that design allowance is not meant to compensate for, we forgot a transformer, or, oh my goodness, we need 4 pumps, not 2, misses of that nature, or we want to expand the plant. It's for picking up nuances in design changes between FEL 3 and whenever the engineering effort's completed. Maybe a nozzle has to be relocated. Maybe the tower grows 2 feet in height. Maybe it gains a few more trays. Maybe the pump impeller design is altered slightly and the new impeller is slightly more expensive. Maybe they change the pump's lubrication design, because there's about 25 different configurations on pumps on how they keep the thing sealed. And so there's all these design allowances that are meant to cover those nuances, and we know they're going to be there. So it's in a way, it's a type of contingency, but at the same time, it's specific. It's for this one particular occurrence. Then we have an MTO allowance. So we're assessing how accurate we think the MTOs are. And because there's design influences beyond moving a nozzle, but it could increase the size of the foundation, or someone could have missed something while they're taking the foundation off, or maybe they didn't miss anything, but they meant to type in 10 and they actually typed in 11, or they meant to type in 100 and they actually only typed in 10. And so there's those type of occurrences. Someone didn't input something into the model that was intended, and so there's one less widget in the model that's downloaded. So that's an MTO allowance. So there needs to be some level of assessment of how accurate, how thorough the quantities are.
is that double dipping? Don't you consider the degree of the design progress inside of the MTO? And then you also consider it in the design allowance, or are those two separate and distinct allowances?
Yes, because the design allowance is really, it's more focused on the technical equipment. It's not applied to everything. But the MTO is looking for mistakes. So in the MTO, if you measured 15 feet and it's really 15 and a half or something of that nature, that would be an MTO allowance. But if they, in the design process, they move the nozzle or they increase the size of a nozzle, then that would be a design allowance. So
Okay. So it's differences in the design where the MTO allowance is a mistake.
yeah, the MTO is either a mistake or it's an omission. I was going to say a commission, but maybe somebody put in too much or forgot to put it in or just mismeasured or calculated something, but it has to do with that process. Meanwhile, the design is that we know that things are going to migrate some, and things rarely migrate to something less. They always seem to migrate to something more. Occasionally you get a little bit of less, but what that would mean is that instead of us putting a factor of 5% on something, because there are things that are overdone, we're really only putting 3 or 3.5.
So if I say the design allowance, it's a change in the design requirements that are usually more stringent.
Well, if more stringent's right. Now you got to remember also, this is I'm focused on industrial. So in a building, the design allowance really would apply more to the MEP side of the building, and I think less to the building structure itself. While the MTO could hit everything. If you were taking off the brick on the side of a building, you could measure the length of the building improperly and increase or decrease your quantity by that missed length, and that would go for us taking off a lineal footage of pipe or conduit or tray, or quantifying the volume of a foundation, a block foundation or something. But the design, let's just say they thought they're going to put a vessel in a particular location with a particular orientation, and therefore you had a nozzle that was going to be 18 inches at 100 feet on the south side. And then after they were trying to fit everything in, the vessel's already been priced, and they realized we got to turn the vessel 30 degrees, and the inlet needs to be 20 inches and it needs to be at 115 feet. Now, if the vessel hasn't been produced already, then raising it 15 feet and turning it 30 degrees won't cost anything because there's no fabrication cost added. But the increased diameter will cost more. Meanwhile, if the change occurred after the vessel had already started fabrication, then the vessel fabricator is going to have to go in, cut out plate, weld plate in, and put the bigger nozzle in a new location. Now there's costs associated with all three aspects of it. And the thing is we don't know, we don't have any idea when the design change will occur and whether and how much it will be affected. So we're looking at the 10,000 foot level saying, well, at this stage of development, his experience history says our process equipment is going to experience a 3% increase in cost across the board. We won't know until it happens which piece of equipment actually incurs that cost. And our E&I is going to increase. It tends to be more, 10 to 15%. Sometimes the tray and conduit's more like 10, and the cabling is what increases 15 because there's a change in where the power distribution center is located or something of that nature. So does that help?
Yeah, I think I got thrown off where it shows in MTO allowances. It says in the second paragraph in that section said the degree of the design process progress. So I thought that was, I thought that was an allowance based on how complete the design is or what stage it's at.
Well, no, what I'm saying there is that as the degree of design changes, as you move from loosely designed to finished design, things change. The design kind of morphs a little bit. Sometimes it changes a lot, sometimes it changes a little bit. But I made the statement there a little bit loose because in this conversation, we don't know exactly where you're having to put the estimate together. Because sometimes we have to put the estimate together in the middle of FEL3, sometimes towards the end. Sometimes they push it and they try to get us to do it early on. And the earlier we perform the task in the FEL phase, the looser the information and the more likely there's going to be change. So if we perform an estimate that's working off of early or mid FEL information, we're going to put a higher design and MTO allowance on it than we are if we're performing it after when the information's almost finished. And then both of those will be less than if we are working off of FEL4 information. Does that make sense?
Yes.
Okay.
More complete. The closer it gets to release to construction, the less allowance you need because you know that everything's included.
Exactly. So the design allowance will keep dropping and it could even get to 0 if you know that this is it, not ever going to change, and that's what they priced. The MTO allowance will really depend upon how, the same thing, how complete's the information, but then also who did it? Did it come out of the model? Did the people that put it together have time? Were they rushed? How experienced were they? As you're wrapping everything up and we're trying to make those decisions, we're trying to analyze that information. In the meantime, we have 2 other allowances that we often place against them. One is what some call it waste, some call it construction practice. And it's somewhat related to actually the MTO is the quality of takeoff. The waste, the construction practice goes back to when I was saying we only needed 18 feet, but we had to buy a 20-foot stick. We only needed 475 feet of cable. We had to buy a 500-foot roll. So that's part of the overbuy. But then whenever you go out into the field and you pull you bought the 500-foot roll and you go out there and you pull the 200-foot run, but you actually pull 15 extra feet on each end. So you've got 230 feet out there pulled now. And as they get ready to terminate, they'll cut and drop some portion of that extra 15 feet. Sometimes they may cut off 5 feet. Sometimes they may cut off and drop 8 feet or 10 feet. Just depends on what they need. And they want to make sure they leave slack in the cable, and all that becomes waste or construction practice. So we apply a little bit of construction practice to all the bulk materials, because that same general tendency can happen in whether it's tray, conduit, cable, whatever it may be. So, and then there's also the potential occurrence of just overbuying something. We'll, particularly with the smaller items where you need 15, somebody actually ordered it twice and now you can't return it. If you can, then you get your money back, but minus some shelving costs. So there's still a loss, but you don't lose near as much. So the overbuy is kind of tied in with having to buy a 500-foot roll when you only need 475 feet, but it's also tied in with you accidentally buy more than you need and you have some cost incurred with that. So we apply a blend of these 4 allowances to all of our quantities. And then we work to make sure we do not consider these when it comes to contingency time, because they're already addressed. Otherwise, you're double dipping on your allowances. Anybody have any questions on these? All right. Well, what I just described is what this says here. So I will keep moving unless anybody has a question. So here, the obvious, because most everybody here is acquainted with quantity takeoff, so don't want to dive into that too much. But the main point of this particular slide is that everything that we take off should be affiliated with a cost code. And since most everyone here is, I think most everybody's affiliated with building construction, y'all are used to the CSI master code, which is now 44 codes versus the old 16. I forget who's dealing with the heavy civil, the municipal work.
I am.
It's like
So what cost code structure are you using?
The same one you have listed there. It's basically identical
Oh, the one that I showed earlier.
in the book. Yes.
Well, that's one thing I want to drop in. Let me see if I can bring this over and if everybody can see it. Is everybody still looking at my PowerPoint slide at this point? Or can
We
you
see the attachment, the sample
Yeah, it's
codes of
like a-
conduct.
Yes, that's it. Okay, good. So I think everybody's pretty familiar with the construction code of the CSI Master Format 95, the 16 codes. That's what I learned on many moons ago. And then they changed it to the 2018, which is now the 44. But we don't, in the industrial side, we don't use this. I think most everybody's using this now on the building construction side, if I'm not mistaken. But have y'all heard of the uniformat structure? The uniformat structure, unlike the CSI master format and industrial structures that I normally see and have used over the past several decades, the uniformat actually represents systems instead of disciplines. So where a system says we're going to install steel, and then we're going to install sheetrock, and then we're going to install brick, the uniformat says we're going to install a wall, and the wall has these components in it. So it's a different look at that type of structure. And the only time I've actually run across it was doing some government work. And then I wanted to jump forward and illustrate what's typical for what industrial. Some of these lists were quite long. Sorry, this is the uniformat here. I think what I was showing before was the breakdown of the CSI 2018 list. But this is uniformat where you have wall finishes, interior wall structures. So it's broken down by system and less by material type. I mean, there is some material separation here, but if you notice, it doesn't say steel, it says shell and the superstructure and the exterior enclosure and roofing. So it's by system, and the system could be several different material types.
The shell means the standing seam or something? Is that what it is?
The shell of the building, which would be the exterior.
Oh, everything. Oh, okay.
Yeah. So they kind of blend things together here. And of course, they say superstructure, and then they talk about foundation and basement construction. To me, I don't know why they just don't call that foundation. And then call the shell the superstructure and the enclosure. But, I didn't make it up. So just because I don't agree with it doesn't mean it's wrong. And they have another portion of it here. So that's the uniformat. And then when I go to some unique structures, this one here, it's a really condensed version of what the Fluor Code of Accounts look like if you worked with Fluor Corporation. And In reality, there's more of these numbers that I'm showing here, and then they break down into multiple levels underneath. It's got several. It has several levels to it, much like the CSI structure. But this gives you a good feel for what it looks like, and the numbering system flows similar to the sequence of construction. On the other hand, another unique set of codes. This is an old set of codes from Brown and Root back in this is what we used back in the 90s. They now have a completely new code structure that's alphanumeric. So this doesn't even exist in use. It's not used anymore. But you can see it has demolition, site improvements, moves into pipelines and piling and concrete and steel. So the sequence is actually very similar to the Fluor structure, but the codes are completely different. These are 9, this is 12, while these would be part of this would be 10 at Fluor, this would be 20 at Fluor. And then all of these in Fluor would be a 0 in a subcode, 00 some subcode. Here it's 8, 7, 6, 4, 3. So very, very different. And then as you're moving through and you hit architectural, they're at 14, Fluor would be at 30 something. And then you get to piping, they're 17, Fluor would be 50. Buildings 15. So the code structures from company to company can vary quite a bit, is the whole concept. But yet the intent is very much the same, and the breakdown is quite similar. So it's at least within industry. It'll obviously, the two that are from industrial work vary somewhat from the CSI, but the intention is very similar. But you have this attachment available to you.
When you say the intention, you mean just the classification? What do you mean by intention?
The intent is to separate like items into a permanent code structure so that you can find it easily and regularly in your system. And it's also meant to standardize the description and standardize unit of measure that's applied to that quantity. That's what I mean by the intention. But then the structure, the code itself may be quite different. As I showed you, we've got several here that are all numeric. And then the uniformat, the whole philosophy is different. Even though the intent's very much the same, the philosophy is different. And then the unit of measure they apply could vary as well. So industrially, and I don't think I need to say too much about building construction because most everybody here is quite familiar with it, knows it well. But industrially, we break it down into earthwork, concrete, structural steel, buildings, architecture. And that goes back to our original conversation that buildings are usually 0 to 5% of our budget. Occasionally it might get up to 10, but that's pretty rare. Mechanical equipment, this is our tanks, pumps, compressors, towers, exchangers, so on and so forth. Piping includes valves, electrical, cabling, wire, conduit, electrical equipment, instrumentation. That's instruments, obviously, but it also can, some companies call it instrumentation, others call it control systems. And it's a combination of the instrumentation that we're installing in the field, plus the control systems that that are placed in the control room that monitor everything. And that includes the software. And there's many programs that monitor plants. Paint, insulation, fireproofing, and then usually there's some other miscellaneous items. If there isn't a code for the other miscellaneous items, then they usually are placed in mechanical or somewhere that's most familiar. One of the items that often may fall into, I don't know what to do with this, would be HSE items. They often are placed in mechanical equipment, but they're not counted because they don't actually drive a process. Another one would be specialty items. Most specialty items are pipe specialty items, so they are all dropped into the piping account normally. I know some companies will place fireproofing, which I note here are separate in structural steel, and some will place them in concrete. Fluor has a separate code account for it. While, like I said, the other companies will place them in here, one, because it's cementitious, or two, because it usually is put on steel. And so they count it that way. Where some of that falls apart and why Fluor separates it in particular is that normally it's a subcontract. And number two, it's not necessarily cementitious. It could be fibrous, but normally it's either cementitious, or it's sprayed on intumescent. So it's a sprayed on application that's about 3/8 of an inch thick, and it just is, if there's a fire, it just keeps expanding until it's burned up. Then you can get, an hour and a half to several hours worth of protection out of it, just like a cementitious, but it adheres directly to the steel. You don't have to have a lot of the expanded metal, and it's lighter, much lighter. It's more expensive as initial application, but by the time you factor in the transportation of it, the handling of it, and the ease of patching the leave outs, the block outs for your connections, it actually is fairly comparable in price to cementitious. We're running tight on time, so I'm going to try to cover this stuff fairly quickly. The items that are captured in site work typically are demolition, clearing, grub, earthwork, soil treatment, culverts, concrete reinforced pipe, parking lot, sidewalks, and so forth, landscaping even. In this slide here, and I'll post this presentation in Canvas probably tonight, and you can take a look at the recommended units of measure. Main thing I want to dive into is that the first task that is being assigned tonight, that's due next Tuesday, it's not due Thursday like the quizzes, but it's due next Tuesday, is focused on calculating area for clear and grub, topsoil removal, asphalt parking, and some of the related items like paint striping and so forth, and then the sidewalk. Then the concrete portion, there's a building foundation, and there's a number of industrial foundations that are pedestals and block foundations. And then there's some grout to take off. So I think the building foundation and these items right here are going to be second nature to most everybody that's listening. So it should be pretty easy for you. And I don't think that you'll find the block foundations or the pedestal foundations difficult. As far as earthwork quantity takeoff is concerned, I'm mentioning a couple of manual takeoff practices here in the next couple of slides. And so obviously you've got two different types of earthwork to calculate and quantify. One is the mass earthwork, and one's what we call isolated. So whenever the opportunity allows, we like the bathtub, which means we'll actually excavate an entire site, or at least a process area where there's a lot of congestion, a lot of foundations. We'll just take the whole site down 4, 5, 6, 10 feet to near the deepest foundation. We'll pour a mud mat either underneath the isolated foundations or across the entire area, depending on how big it is and how many foundations there are concentrated in there. And then we'll backfill against all of those foundations, but we'll also run a lot of our underground piping in there, as well as some of our grounding cabling. So that we can excavate it once, install everything, backfill it at once, and you've only handled the dirt one time. Versus years ago, the method was get the site ready, excavate what you have to, backfill, get everything within a foot of finished elevation, then go back and dig out each individual item. And so you're handling the dirt 2-3 times. Handle it once to get the earth in place, handle it again when you dig the isolated foundation, then you'd handle it again whenever you excavated through the middle of the foundations, dropping in your underground piping. It's very, very costly, inefficient, but you had access to the site. Now you have a large bathtub that's all lowered, and basically if you have a massive rain, it's now literally a bathtub or a swimming pool. So you have to take into consideration, how are we going to get the water out of here if we have a lot of rain? So you should be designing it so you got a low spot, it slopes in a certain direction, and that's why we put the mud mat down, so that you can operate in what would have been a mud pit. Now it's just a weak concrete surface that you can drive on and walk on. There's a couple of manual processes. The reason, obviously, the most modern and easy way to go about it is to use a digitizer. And if you have the proper software, you can actually calculate quite a bit pretty quickly and pretty easily. I don't have that system available to demonstrate or use, so I'm mentioning some manual methods in case you're ever in a position that you have to come up with something and you don't have a digitizer in hand. One is the grid pattern, the other is a cross-sectional pattern, where you are superimposing a grid over the initial and the final layout of the land, your topography, and you're calculating the difference in elevation, and you're averaging across each one of those squares. So you're going to come up with an average excavation or average backfill. On the other hand, the cross-sectional method would be, if you have a cross-section of your site that's so many intervals, and you know what your net, well, you know what your excavation needs to be and what your backfill needs to be, because you don't necessarily want to focus just on the net, but you want to know how much you have to excavate and how much you have to backfill in different areas. Then you average that across your intervals, and you should come up with something representative. Obviously, if you're using a digitizer, I think you're going to come up with a much more accurate calculation, because in both of these methods, you're operating off the concept of the law of averages. And so you can either over calculate or under calculate based upon how tight those squares are, your area grid is, and how many cross-sectional views you have of your land. Because as the grid pattern gets larger and the intervals between your cross-section get farther apart, you're going to be less and less accurate in your takeoff. But I've had to use these options in the past because I didn't have a digitizer available, and we had to come up with something. And so we made it work. Another one that I would offer to you is Bluebeam. Now, Bluebeam is a little bit more like on screen, but I've been able to use it to quantify lengths, quantify areas, and then by quantifying the areas, I've been able to kind of transpose that into a volume if I knew what the height was. So Bluebeam is, even though it's a replacement for Adobe Acrobat creating PDFs, it's really, I'm finding it to be a combination of on-screen and Adobe Acrobat and PowerPoint kind of blended together in a way, but not so much PowerPoint, but the other two for sure. Whenever you take it off, keep in mind that you have all of these type of items. You got the pour, you've got the formwork, you've got rebar embeds. You may have to rub it, which would be another surface area chamfer. water joints and water stops, depending upon what type it is. You don't have any water stops in the foundations I've given you, and then the mud mats.
The chamfer, I'm sorry, it's been a while since I did this. Chamfer is the corner of the foundation or the section. You create like a 45-degree thing
Yes,
in it.
to keep the concrete from tipping. Yes, that's it.
Yeah,
It's
yeah,
about inch by an inch or 3/4 by 3/4.
Yeah.
We normally, I mean, I've seen places where we haven't used it, but normally we use it if it's a finished surface.
I mean, if it's exposed, the top is
Yes.
exposed. Okay.
Yes.
No,
Or
we
there's not-
usually, yeah, if it's buried, you don't care for it.
And even if it's not buried, if you have another pour going right on top of it,
Oh,
we
okay.
typically wouldn't put it on there. But if it's if something's going to set on it that's smaller, then we would, because now you have the chance of it being chipped. That's been my experience. If anybody else sees something different, that'd be great to hear it. One thing we use in our practice, and it's really a floor creation, but I've been employed by a couple of other companies that remarkably had the same exact template. So Fluor and other companies develop things and do their best to keep it proprietary, but it never stays that way. And what it is, it's a model. It's just printed on a sheet of paper, but it gives you a little illustration of 25 different foundation types, and then underneath it gives you a set of ratios. It's almost like a model of per cubic yard of concrete. You have so many square foot of contact area of formwork, so many pounds of rebar, so many expected embeds per cubic yard, and so many man hours to handle, install it, and finish it. And it's real handy. I know a few years ago they were revising it because modern design has been beefing up the amount of rebar in the foundations, and so they were reassessing the rebar portion. But outside of that, it's a very handy little model. If you don't have that, then you basically have to take all this off separately and estimate it piece by piece. If you have a model like that, and you know that per those other items are part of a type of pour, then you can develop a unit cost for a type 3 foundation or a type 10 foundation cost per cubic yard. And then you got to do is calculate the cubic yards of that foundation, apply it times your unit rate, and you're done. You don't have to take all this off one time, and you're done with all light foundations, even as the size changes. It's very handy. But that's more of a modeling concept versus a very detailed concept here. Last thing we'll say, because we're already over by 6 minutes. Grout is taken off in cubic feet. The surface underneath the grout typically has to be chiseled, and so that the grout would adhere. For moving, rotating equipment, you normally need to install epoxy grout, and for static equipment or steel structural items like what we're seeing in the picture here, cementitious non-shrink is good, is fine. The pricing continues to increase, so cost per cubic foot for cementitious non-shrink, I think these days is like $160 a cubic foot now. It's become pretty expensive, and the epoxy, if I remember correctly, it's running like $260 to $290 per cubic foot, and then you add your labor to roughen the surface and handle and pour and form them. That's even more. So we normally run around 4 hours per cubic foot for cementitious and 9 hours per cubic foot for your epoxy. The epoxy, when we're pouring that, we're actually filling up the bases of the pumps and the compressors completely. And so it's doing one of two things. It's getting rid of the voids underneath the equipment so there's no opportunity for any type of explosive gas to build up in there. But also, and even more importantly, it's creating a gravity base to help control vibration in the rotating equipment. So the cementitious is just helping support. So in the middle of that, obviously, is going to be a shim pack that you've actually set everything on, and then the rest of it's filled in with the grout. So there's no requirement to take off the shims. That's usually an allowance anyway. But the task does have you taken off quantity for grout. And here's an example right here. This is a foundation for a large pump, and you can see the holes that they're using to pour the epoxy grout in. And when it all fills up, it'll come out the top, and then they strike it off, and they know they're full. They'll tap it to make sure that there's no air pockets in there. But so again, this class is open this Thursday. We'll be working on task 1. I will do my best to be able to break everybody out into work sessions, break rooms. And then the task is due 6 p.m. next Tuesday. I think y'all will have a fairly easy time with this one, other than the fact that the foundation, the building foundation, I found fairly difficult to read. Because I'm taking off all this myself also. So along with you.